Welcome back. Hononegah Honors Algebra 2. We're in a new year. 6-1 to 6-4 quiz review. We did 6-1, 6-2, 6-3 prior to winter break. Now doing 6-4 after winter break and taking review on it. So this is going to be a little bit challenging. It's going to test your uh, basically your remote learning abilities. So let's go through all this. If you have any questions, make sure you talk to your teacher. But 6-1 to 6-4 quiz review. Determine whether the function represents exponential growth or decay, and then graph. So your graphing calculator could come into play here. I'm going to do a little XY chart, but because you have a fraction or something below 1, I shouldn't say fraction, that was a poor, something between 0 and 1 as your base raised to the x power, this would be exponential decay. Now, the XY charts you can use a graphing calculator maybe to help you with. You can do numbers like -1 for x, you would get 4. 0 for x, you would get 1. 1 for x, you'd get 1/4 or 0.25. So using a little color here, -1, 4, 1, a fourth. So again, it does not cross the x-axis. That is the asymptote. So it's going to continue to get closer and closer and closer, but it will not cross. So please be careful on your graphs so that you make sure that it doesn't cross the x-axis. Next one. Because, now again, this was me saying something bad. Because this is above 1, this would be exponential growth. So when I previously said fraction, that was something I should not have said. But so I'm going to probably type this into my graphing calculator to get 5/3 raised to the x power. And so this would be growth. So I'm going to make an XY chart. And again, I'm going to pull these off the graphing calculator. 1 is going to be 5/3. I know that. 0 is going to be 1, so I know that. -1 is going to be 3/5. 2 would be 25/3. So again, just trying to come up with some numbers here to graph. So if I put 2 in, I get 8 1/3, 8.3. 1, I get 5/3. 1, 3/5. So again, going along the x-axis and then going up exponentially, but it does not cross the x-axis. E, so again, probably using a graphing calculator even more here, to a negative power, this would be exponential decay. And now for my XY chart, they're going to do a lot of decimals now. So e raised to the -0.5x. And I'm going to do an XY chart here. Give me 1 second. All right. So plugging in some numbers here. Looks like negative, I'm going to go a little further. -4, 7.4. -1, 1.601. 1.6. And so that gives me a good idea of what to graph. So -4. 1, 2, 3, 4, 5, 6, 7. -1, 1.6, and then 1, and then it's going to keep getting smaller and smaller and smaller as an exponential decay. Next one, we got e to a positive power. So this is going to be exponential growth. And again, going to make an XY chart and use a graphing calculator here. So I'm going to go y equals 2e raised to the 2x. And so -1.302, 1, 14.8. So that's about all I can do here. So 1 goes off the graph. 0, 2.3. So this one goes up pretty fast. Next. Population of a city has decreased at a steady rate of 0.47% each year. If the population in 2015 was 240,000, Sorry for the interruption there. Write the exponential decay model for the population where t is the number of years since 2015. So I want a model. So we're talking about what did it initially start at in 2015? Well, 240,000. 1 minus, now the R. A lot of people are going to get this wrong. 0.47% is 0.0047 raised to the t. So writing the model, I need to take 1 minus 0.0047 and get 0.9953. So the decay factor is 0.9953. Now, predict the population in 2021. Be careful. It started off in 2015. So now we're really only talking about putting in a 6 for t. So now pull out your calculator, 2400, 0.9953 raised to the 6th power. And so, hold on a second, not sure why I did that. It's not 2,400, it's 240,000. So let's go back here just a little bit. 240,000, 0.9953 raised to the t. Not sure why I left off a couple of zeros there. So 240,000 times 0.953 raised to the 6. So we're talking about 233311. And because we're not going to do, we're going to round this to the nearest person. So we're talking about 233,000 people. Sorry about that. The value of the house in thousands of dollars can be approximated. So remember, this is in thousands. So that's 260, but that's in thousands. Where t is the number of years since. What is the percent of increase? So what they want to know is what is r. So if 1 plus r is, so you're talking, subtract 1, 0.015 or 1.5%. Estimate what the value would be when they approximate 302,000. So they want to know if I ended with 302,000. So now I don't need to actually put 302,000. I just need to put 302. So here's what they want me to do on a graphing calculator. And I will pull up a graphing calculator here. So give me 1 second. I'm going to pull up a graphing calculator because I want to approximate when t is. So I'm going to pull up that graphing calculator now, and I'm going to type in the model. So y equals 260, 1.015 raised to the t, and we're just going to use an x on the graphing calculator. So I went to y equals, and I need to, whoops, I need to fix this. So we're going to insert a parenthesis there. I'm just going to start over, make it easier. 260, 1.015 raised to the, let's go back, parenthesis, raised to the x. All right, so I want to know when it's 302. I want to know how long is it going to take. So I'm going to have to scroll down here and see when it gets to 302. And it looks like just a little over 10 years. So if I was going to estimate when the value would be approximately 302,000, a little over 10 years. Next one. Giving you a formula again. You deposit $250 in your account, 1.25% annual interest, compounded quarterly. Find the balance after 3 years. So I'm going to put in $250, 0.0125 quarterly, so 4 times a year. And so we're going to do that for 3 years. So on my calculator, again, I'm going to pull it up here, 250. I need to figure out what 0.0125 divided by 4 is. So plus 1. So this is 1.003125 raised to the 12. So now pulling out a calculator again, 250 times 1.003125 raised to the 12th power, and I'm going to get 259.54, and this is money. Next, another investment accounts your house, its education earn. Investment accounts for a house and education earn annual interest compounded continuously. You deposit 4,567 in an account for the house, and that earns 4% annual interest continuously. The graph shows the balance of the education fund. So here's the education fund. And now write a model that represents the house fund. So A equals, we're going to put $4,567, E raised to the R, so 0.04, and T. So there's the model. Find the balance of the house of the account after 6 years and compare it with the education. So 6 years. So over here on the 6 years, it's a little over 6,000. All right. Now let's see if we put 6 years in for T and see what happens. So 4, 5, 6, 7, E raised to the 0.04 times 6, and I get $5,805.79. So just comparing the two, this is our house fund, and this is our education fund, and I would say our education, ed fund, is higher. Rewrite. All right, so now we're going to do a little bit of logarithms. This is the spiral technique, okay? 4 logs equal exponents, remember. So base, exponent. So 4 to the third power equals 64, and 16 to the second equals 256. So this is writing logarithmic form into exponent form. And so the next one, what is the base? Well, the base is 1/3, and the exponent is -2. And remember, logs equal exponents. So the base is 1/5, and the exponent is -4. So writing something in logarithmic form. Evaluate, and this is where your calculator is going to come into play. And this is, I'm not a big fan of this section. It is on your quiz, but we're going to set this equal to x and put it in exponent form. And so what they're asking is, what x to what power would equal 16? Well, if you get the bases to be the same, then that tells you what the exponent would be. So this is 3 to x would equal 81. So it's asking what power of x, or what power of 3, sorry, would get you 81. And since 81 is 3 to the 4th, then the answer to this question is 4. It gets a little more complicated when you start dealing with fractions. So 1/16 is 4 to the -2nd power, which means x has to be -2. And the last one, 1/25 is 5 to the -3rd power. Graphing. So you cannot really graph in logarithmic form. You really want to change this into exponent form and then do an XY chart. And instead of putting numbers in for X, you're actually going to put numbers in for Y. So if I put -2 in for Y, okay, that is 1/9. If I put -1 in for Y, that's 1/3. And 0 in for Y, that's 1. And 1 in for Y is 3, or 2 in for Y is 9. So you're graphing something that it looks like an exponential growth, but it's actually a logarithmic function. So it's the inverse of an exponential growth question. So changing this into exponent form, we're doing an XY chart, and instead of putting numbers in for X, we're going to put numbers in for Y. So if I put -2 in for Y and -1 in for Y. And so again, this is an exponential, it looks like an exponential growth, but it's a little bit different. So 4, -2 to -1. And so this is the inverse of an exponential growth. Describe the transformation. So basically they want me to, what happened to the, from one to the other. So f of x is equal to 5 raised to the x power. G of x is 5 raised to the negative 3x minus 6. So there's two things that happened there. There's a negative sign, and then they replaced x with a 3. So we're talking about a reflection on the y-axis, because that gets you the negative then. Then you're talking about a horizontal shrink by a third. That replaced x with 3x. And now you're talking about a translation down 6. And that would get you the minus 6 at the end. So the next one, how to get the 1/6 in front? That's a vertical shrink by a 6th. Then they replaced x with x plus 2, so that is a translation to the left. That is a horrible left. Let me write that again. Left 2, and then another translation down 1. And the last one then, how to get the negative out in front? That is a reflection on the x-axis. Half means that's a vertical shrink by a half. And they replaced x with x minus 4, so that is a translation to the right 4. Write the rule. So they're starting off, they're giving you a function to start with, and then they want you to do the rule. So a horizontal stretch by a factor of 2. So now I am replacing x with a half x, followed by a translation up 4. So I'm adding 4 to the function, and that's the new g. A vertical shrink by a factor of a half. So I'm going to multiply the function by a half, and the translation 3 units to the right and 6 units. And I can't read this, so hold on, I'm going to hit pause. All right, I'm back. It does say, I think, 6 units up. Yeah, 6 units up. So I just had to move that over just a little bit so I can read that. So I want to go 3 units to the right. So I'm going to replace x with x minus 3. And then I'm going to add 6 to go up. And that is your new g function. So again, those of you that are still struggling with this, write the rule for g that represents the indicated transformation. So vertical stretch by a factor of 3. So if I want to go vertical stretch by 3, I need to multiply the function by 3. So I'm going to multiply the function by 3. 6 units to the left. So now I'm going to replace x with x minus, to the left, x plus 6, and then up 3. So my new g function. Next one's a log. I'm going to do a horizontal shrink by a 4th. So I'm going to replace x with 4x. So I replace the x with a 4x, followed by reflection on the y-axis. So I'm going to replace x with a negative. So I've got a negative 4x, and that is my new g function. Your homework assignment is to study for your 6-1 to 6-4 test. And then we're also going to do a flip situation, I believe, so be ready to talk to your teacher about what we're going to do with section 6-5. And good luck.